All right, guys. So a couple of you asked about this question, so I thought I'd put it together for you and hopefully help you be able to answer it. I'm going to go ahead and go through the whole thing. You don't need to watch the whole video, just watch the pieces that you need. All right, so we have a water container made in the shape of a cylinder with internal height h and internal base radius r. Okay, so that's the first thing we got. We got a cylinder. Okay, and we need to be able to understand what's going on even if they don't give us a picture. It says the internal height, so that would be the height right here. And then it also says there's a base radius of r, so that's inside right there. So basically they're giving us everything we need to know in order to be able to find anything about the cylinder. All right, the water container has no top, so the top is open. The bottom, of course, is closed because it's a container. The inner surfaces of the container are to be coated with a water-resistant material. Write down a formula for A, the surface area to be coated. All right, so the first thing, you can get some of these formulas in your formula packet, and you should go ahead and check that out if you need to. But really, there's two things that we need, right? We need the circle on the bottom. That's part of the interior, and that's a circle. So the area of the circle is pi r squared, right? That's the area of a circle, gives us the radius, which is r, so we should have the pi r squared, okay? The second thing that we need is the area of the rectangular part, right? Remember, for a cylinder, the outside or the flat part is just a rectangle that's been wrapped around. If you think of like a can, the label of the can, if you were to rip the label off a can, it's just a rectangle, right? Now, that rectangle, okay, will have a height of h because that's how high that label needs to be, and then the length is going to be how far it takes to get all the way around. Now that's a circle of which we know the radius being r, and we know that the circumference of a circle is 2 pi r. So therefore, the area of that rectangular part going around is the base times the height, 2 pi r times h. And so therefore we just add the 2 pi r times h. And all of that put together gives us the total area of surface area that needs to be coated, right? Now, if I needed to coat the top as well, then I'd just put a 2 in front of the pi r squared there. But in this situation, I don't need to coat that because there is no top. All right, so that's part A. Moving on to part B, it says the volume of the water container is 0.5 meters cubed. And so if we take that 0.5 meters cubed, we're going to need to do a transformation, oh man, my brain's not working today. We need to do a conversion. It wants us to do it in centimeters cubed. So the first thing I need to do is take one of those meters and turn it into centimeters, okay? And then I put it over meters. But that's only going to do one of those meters, right? This is meters cubed. I know that there's 100 centimeters in 1 meter, okay? Now that's going to take care of one of those meters. It's only going to cancel out one of them. I need to do that 3 times because it is meters cubed, okay? Now when you do this, I've got meters cubed on the bottom, meters cubed on the top, so those are going to cancel out. And I do 0.5 times 100 times 100 times 100, which will give me the final answer for part B. Sorry, that was part A. For part B, which would be 500,000 centimeters cubed. And you just multiply those out on your calculator, and you should get this number here. All right. Okay, let's move on to letter C. I need a little bit more space here. So it says write down in terms of R and H an equation for the volume of the water container. Okay, now the volume again is something that you can get almost directly from your formula packet, but for a cylinder, it's just the area of the base times the height. So the area of the base we talked about before, that's that red piece right there, the pi r squared. So the volume is going to be pi r squared, and so that's the area of this, and then we're going to multiply that by the height. It's kind of like when you have a cube or some type of rectangular prism, right? And in the rectangular prism, you do the base times the width, which gives you this area right here, the bottom, and then you multiply it by the height, it's exactly the same idea. You're getting the area of the bottom, multiplying it by the height. That's how you get the volume of any prism. And a cylinder is just a prism that has a circular base. So pi r squared times h. And that should then be letter C to give us the volume. Okay. Though I guess technically we do know that the volume is 500,000 centimeters cubed. So if you wanted, you could say 500,000 equals pi r squared h. That's actually probably better because in part C it does say write down in terms of r and h, and it doesn't have a v there, so we should put the volume in there since we know the volume now. Okay. All right, so we'll move on to the next part of this question. The water container is designed so that the area to be coated is minimized. So what we're trying to do here is show that the area is pi r squared times, sorry, there should be a plus there, plus 1 million over r. Okay. Now, in order to do this, we're going to need both of the pieces from the prior questions, right? So the first question we had was that the area equals, this is from part A, pi r squared plus 2 pi r h. The second part that we were just doing was for the volume, where we said that the volume was 500,000 equals pi r squared h. So what they want us to do now is have a formula for area that has only r. So that means in my area formula, I need to get rid of my h. Well, in order to get rid of the h, I need to write h in terms of r. So that's what I'm going to do with this volume right here, is I'm going to divide by pi r squared. So I'm going to have 500,000 divided by pi r squared, and that equals h. Right? Because I've done that, I can now take this and put it in for h. And that's what they want you to show in this part D, is that when I do that, I now have, and I'm going to copy this a exactly as it is, a equals pi r squared plus 2 pi r, and then times h, which is 500,000 over pi r squared. And when we do that, you can see the pi's cancel out. You can see that one of the r's cancel out, leaving us with this right here. 2 times 500,000 is 1,000,000, which is what you got on the top, and then you got the r still left on the bottom. Okay, so that is letter D. Now, letter E asks us to find the derivative, dA dr. All right, so in order to do that, I'm going to rewrite it. I'm going to go ahead and do it down here at the bottom. A equals pi r squared plus 1,000,000 over r. Now, one of the things that you need to remember is that when you have a fraction with an r on the bottom, we actually don't know how to take the derivative of that. Okay, so what we need to do is we need to rewrite it so that it's in terms of an exponent like this. Okay, so we're going to rewrite it as a equals pi r squared. Remember, when you have a variable on the bottom, that's r to the first power, you can bring it up to the top and change the exponent so that it's negative. So I've got 1,000,000 r to the negative 1. Okay, at this point, you can now take the derivative, right? So now we're going to take the derivative dA dr. And so here we'll take the 2 and bring it in front and subtract 1. And so that'll give us 2 pi r. And the 2 minus 1 is 1, so that's just r. Plus, sorry, take the negative 1, put it in front. So that's actually going to be a minus now. Okay, minus 1,000,000. And then if I subtract 1 from negative 1, negative 1 minus 1, so I got to go 1 lower, or you could change that to a plus a negative. That means I've got 2 negative 1s there, so that means I'm going to have r to the negative 2. All right, so that is the derivative. Okay, now this idea, a couple of you had issues with questions on the calculus the cold calculus catastrophe, use this idea anytime you have a variable on the bottom. Move it up to the top, make the exponent negative. All right. So now we move on to part F, where it says, using your part to answer E, find the value of R which minimizes A. To minimize, remember to minimize A, we set the derivative equal to 0. So we just say 0 equals 2 pi r minus 1 million, yep, r to the negative 2. And you should be able to end solve this. You could do some algebra as well, but with your calculator you should be able to end solve it. And if you end solve it, or you could graph it as well, either one of those, but you should be able to get that r is equal to about 54.2 centimeters. All right, so make sure, put that in, make sure you can get that answer. All right. The next part of the question is, well, you just found the radius that would give you the minimum area. Now what you need to do is find the value of the minimum area. And so remember, we've got a formula for area here up at the top. Change colors, here we go. You got a formula for area, so let's go ahead. For part G now, the area is going to equal pi times r is going to be 54.2 squared plus 1 million all over 54.2. And when you work that out, please, actually, when you're doing this, I wrote down 54.2, but you need to keep all the digits, right? This answer down here was a rounded answer that I rounded to 3 sig figs, just like I should when I'm writing down the answer. But when you're doing a calculation, you need to put all the digits there. Okay, so do as best you can. If you can't, if you forget how to use that feature on your calculator, then at least put down the first 5 or 6 digits so that there's no problem. All right, the answer should be a little more than 27,000. Because I'm writing to 3 sig figs, I'm going to have 27,700. Okay, it was 600 something, like 679 or something, but I'm rounding it up because my answers, according to IB, can have 3 sig figs, and at that point, that's it. Okay. At this point, it says 1 can of water-resistant material coats a surface area of 2,000 centimeters squared. Find the least number of cans of water-resistant material that will coat the area in part G. So we're going to take our answer. We're going to divide it by 2,000, and you should get 13.84. But I can't buy that many cans, so the answer is 14 cans of coat, whatever that is. And that's your final answer. Okay, so hopefully that was helpful in working through that question. Let me know if you have any other questions as you work through the calculus stuff, all right? This is a good chance to be able to review before we get into our mocks. Awesome, thanks.